with this?
Yeah, try that.
Yeah? You like it? Close my Skype.
Thanks. He's trying to transport it.
Too late for that.
If I get overwhelmed, then the audio turns off.
Good, you? Hey, come here.
This will be on the test.
mic or I forgot?
Doesn't matter. Do you guys want me to use the mic or?
Yeah, we got our mic up and ready to go. You okay with that?
Do you want to use it?
We'll get you to get this one on.
Oh, there's two of them?
There are two, yes, that's what you need.
Oh my gosh, you guys are
Yeah.
amazing. You're so
This
organized.
one's for the internet feed. That one's for the room. We don't have a fancy enough room yet that we can just tap into their system. One day.
Okay. Or you can put your slides now if you want. I'll just wait for you to
Wait, the yellow shirts, the yellow shirts.
and then I'll just do a couple quick announcements and then hand it over.
Mm-hmm.
Okay. Oh. I guess that mic is on. So welcome everyone to the November 2018 Quality Talk. I'm Tina Fletcher, your KWSQA president. I just have a couple of quick announcements before we get started. So the first one is that this is the last meeting of the year. As usual, we are not planning a meeting in December. So the next time we will all get together is end of January of 2019. Another announcement, or I guess a call for help maybe, is that we're still looking for the next company who would like to partner with us on a testing games event. The last one of those that we did was in August, I think. And so we'd love to host another one. We're just looking for a company who's got something that they would like tested. So if you think that your company might be interested, find somebody wearing a yellow shirt and let us know, or you can email us info@kwsqa.org. Third and final announcement is that we've got a little bit of leftover swag from targeting quality this year. There are some pens and some cooler bags, and right now they're just at the back of the room. So if you feel like you would like to have one of those, maybe you didn't get to attend the conference this year, or you did and you just really love your cooler bag and want another one, you can grab some on the way out. And so that's all for announcements. I will now introduce today's speaker. Today we have Sarah McKenna, who has come all the way from New York City to speak for us today. And I had the chance to hang out with her a little bit last night and hear a bit about her career, which has been very diverse and interesting and all around, in and around QA and testing. And so today she's going to tell us a little bit about ways that she's been using big data and analytics to help improve quality in her work. So I will now turn it over to Sarah. Welcome.
Thank you so much. Thanks, everyone.
You need to wear this one as well.
I have to wear both?
Yeah.
Okay. Sorry, let me do that. All right. Okay, so this is a riff off of the motto of my current company. We do web data extraction, so we are laser focused on data. But I'm hoping today that you guys get a lot of ideas from what we've been doing in how to use your own data to improve your QA processes and your overall testing lives, less firefighting. So my story is, at the moment, I don't know, at a startup, so I have a lot of titles. You know, I'm heading up sales and product strategy and operations for a web data extraction product and services company. We're also creating data products. The primary vertical that we're selling into is alternative data and finance. So I work with a lot of quants on a daily basis and data strategists who are using data to make investment-driven data decisions. So I'm very much sort of steeped in the world of using big data and analytics to create value. But what I'm going to tell you today, I'm basically going to go through a story of how I initially implemented this at a previous company, hoping to share some ideas with you guys. So my background in New York City, I've worked there my whole life, starting in 1997, doing various startups. I've done a couple of large organizations. We got acquired by Microsoft, so I worked there for a few years. I also worked under Bloomberg at the New York City Department of Education when we were trying to improve outcomes for students using technology. I ran their testing. I worked exclusively in QA roles until about 2015 when I moved into the data dev management role and took over, based on my automation experiences, took over the data acquisition technology for a different web data extraction company. So as I said, we're laser focused on data quality, and what my forward focus is, and I'm hoping to get you guys excited about this as well, is basically looking for ways to incorporate more AI and machine learning into what we're doing, into our data quality approaches. So what I've seen over over my career is that there's been a really significant shift in approaches to testing and thinking about testing, and obviously you guys have seen this as well. Back in the day, we used to get the software thrown over the wall, and we would just sort of think of ways to test it. It wasn't a terribly structured process, and then Agile came along, and all of these open source tool sets came along, and we have, today, I think, a very established DevOps orientation, looking, where people just expect to have sort of well-formed and well-thought-through and working regression test sets to support a rapid delivery process. And those are all based on the assumptions that all software has bugs, and it's based on the assumptions that we need to, we basically establish standards and we follow best practices. And that's, I think that is sort of going to feed into the next wave, which is probably more focused on AI and ML. And it's going to be, I think a lot of it's going to be data driven. It's a very interesting time. So let me tell you the story of the first time I came across a problem where we decided to use big data and analytics to solve QA problems. So this was my first role outside formal QA. So we basically, these private equity guys recruited me to their company, which was in shambles. They were facing an existential threat from quality. They were pulling data from websites and selling it into the travel industry and the retail industry, into the yield optimization, pricing optimization engines. And they were blocked on a lot of sites, and they couldn't get the data, and they didn't know what was going wrong, and all their customers were complaining. They had tremendous revenues, and they, in prior years, had fantastic profits, but the travel and retail sites had picked up on bots, and this company that had been around for 15 years, suddenly they were getting blocked, and they didn't know how to get around it. And they couldn't see what was happening, and it was just the people. They had 300 employees, and they were in a world of pain. They had 15-year-old legacy systems. The private equity guys had fired the original teams that had built all the systems. So there was like a team in India that hadn't even been really properly transitioned. And so they were responsible for these things. They kept going down. They had recently migrated everything from an old failing data center to AWS, and they were learning there too, and there were all kinds of kinks and things to work out, things to optimize. They didn't really have auto scale. They didn't have self-healing systems, and they had this sprawling, tons and tons of components. They use, and anytime you're doing web data extraction, you're going to have proxies in the mix where you're routing your requests through proxies. So for example, if you want to get a price off of Priceline, you're going to get a different price if you're coming from a Japanese IP than if you're coming from a Waterloo IP. So you're proxying everything. They had their own proxy infrastructure, which was also old and crumbling and failing. And they had third-party proxies that they were integrating more and more to get around a lot of the bot blocking techniques that sites were adopting. And they never knew when those things were down. They didn't know if they were a source of an error or something else was a source of an error. And of course, they're going against third-party sites, and you don't know what they're doing. They may be doing A/B testing. They may be doing an upgrade. They may just be down. It may just be a really buggy site. Or maybe they've just added window dressing for the holidays, and everything that you have is just broken. Because of the cost of the scale of this operation was enormous, and because of the cost of all of the infrastructure, it was basically not feasible to create voluminous logs for the scripts that were running. The disk, the cost of those disks and the cost of the storage for all of the data was just too high, and we needed to think of something else. What else? There were all kinds of problems. Like we had great change tracking on code check-ins to SVN, but then we had all these configurations in the system, and there was really no tracking there. So they were very difficult to see when a change has caused an issue. And what was happening was basically every little problem was creating big ramifications, and the company was, as I said, facing sort of an existential threat. They really didn't know how to proceed. And they had, they were running about 80 million requests a day, billions of rows of data extracted every day. They already had 12 multi-terabyte Postgres databases that were sharded daily, and the database infrastructure alone was $220,000 a year, so we couldn't, just sort of pile on that. Really needed to think outside the box and come up with something new. So we were in a world of pain, and what they had in place were, a lot of people who were sort of manually looking at output files, spot checking, and trying to find problems before they happened, and it wasn't working at all. Customers were calling in the issues 3 weeks after they had happened, or sometimes a month after they had happened, and nobody inside the company even knew something had changed. So we established some goals. We wanted to figure out how to have a centralized data store that we could use to detect errors. Let's start with detecting errors before we start automatically handling them. We wanted to make sure to build it outside the production systems that were already extremely brittle and couldn't handle any more load. We wanted to use open source libraries exclusively because we didn't have any more budget to invest in licenses. We wanted to use what was free and what would be fastest to get in place. We wanted to figure out some way to do real-time monitoring of what was going wrong. And we also we didn't want to fire a bunch of staff and hire a bunch of new people. We wanted to use the people we had, which were not, a lot of the folks that were sitting around manually trying to find out what these errors were, if there were errors, were not skilled. So we wanted to have an interface that was easy for people to use to detect what was going wrong so they could fix what was happening. And then eventually, once we had that in place, we wanted to automate error handling wherever we could. So we made a bunch of choices. We decided that the way we were going to collect data outside the system was by building a centralized proxy management system, which we needed anyway. And we figured we could get all of the scripts going through the proxy system, and then we could write all the data going through the proxies to a central store and build off of that. So for that, we used Little Proxy, which is a great little tool. It actually hasn't been updated much since then, as open source libraries go. And they had a man-in-the-middle extension, so we didn't have to worry about content, being encrypted. And so we set that up, and we set it up to auto-scale. So for each instance of a script, we would create an instance of a proxy, and that was, managed by a proxy manager. And that was all auto-scaled in AWS, so it wasn't too expensive. And then we set up MongoDB as our data store. And there wasn't a lot of thought that went into that. It was free, it was cheap. As opposed to our Postgres multi-terabyte databases, which were hundreds of thousands of dollars every year. You know, at the time, the cost for MongoDB was $23 a terabyte a month. So it was really very small cost. And they had mirroring and failover and things that we could just take advantage of, you know, as part of AWS. The anonymity manager we built basically interfaced with the core job system. And it would, you know, periodically pull the, you know, all of the script-specific configurations. So we had the org and the account that was the customer, the app, whether it was travel or retail, for example. They were different applications. And then the site, you know, whatever site it was Walmart, KWality. So we stored all of that in the anonymity manager. We used a relational database for that in AWS. And then we used Spark to basically analyze the reams of data and React.js to display it. And that combination was pretty fast. And then we also set up Sentry.io to do, to basically capture the errors that the proxy manager and anonymity manager were throwing off. It is an amazing library for capturing errors. And you can, because we were building proxy manager and anonymity manager from scratch, we could set it up to send their errors out to a cloud service. We didn't pay for anything special. I think we paid $7 a month or something. And that was enough. You know, we get an alert from them every time we exceeded our quota for errors, and that would tell us to go look that something was going wrong. So that's how we used that. They do have libraries, open source, that you can install on your own infrastructure and set up. And I think if I had more engineers and more time, I probably would have done that. So we set up a master collection. To start with, we needed to have some master collection. We knew it was going to be enormous, so our retention time was going to be very brief, right? So we set up for a retention time of 1 or 2 days. We stored everything that the scripts told Anonymity Manager they needed. So basically, you know, what org and account they were with, what their run ID, work unit ID, line item ID was. That would tell us exactly what, you know, input it was running and through the script at that moment for what customer, what geography they were coming from, and then of course the site and app information, a date, and then we would record the response. So we'd record the request, all the details with the request, and then all the details with the response. So we'd get the HTTP status, we would get you know, all the information that came across the wire, and the start and the end time of that response. So we could do analytics on it. So we had to update, you know, all the scripts, 3,000 scripts, to work with this proxy manager, and that was probably the biggest piece of work in the whole project. But it was necessary pain because we had to centralize everything if we were going to get any value out of this. You know, so we clearly defined all the parameters and created REST APIs, you know, that they could easily call. And you know, we had nice documentation. We used Swagger to document our APIs. So it was incredibly easy for we had 80 script developers to go and look things up and test things out when they weren't working. They didn't have to come through us. So that was a pretty smooth process. And then we also included in that interaction the script. We gave the script the ability to report an IP as bad. So only the script knows if it's getting blocked by the site. You know, it might be in status code, an HTTP status code of 200. If it's displaying a beautiful page that says, we think you're a bot and we're not going to let you in, right? So that's not going to trigger an error at the analytical level unless the script says, hey, I was blocked. Mark this IP down, I was blocked. So we added bad IP handling in and stored that. And that was sort of the quickest, lowest hanging fruit. So we were able to immediately, you know, if we got 2 bad IP requests from the same site code within an hour, or within 15 minutes even, we would just take it out of rotation for that site. And then we had the ability to set an expire time on, the bad IP, for how long that IP would remain out of rotation for that script. So, some sites it would be, 1 hour, and some sites it would be permanent, some sites it would be 2 weeks. So that meant that the IPs that were already blocked on a site were basically taken out of rotation for that site, and that was a huge, that had a huge impact immediately. So everyone was really pumped, really psyched, really happy to move forward with helping us get all this done. Then we started creating, then we set up the alerts and notification module. So we were basically emailing folks on a site-by-site basis. We created collections. We have the master store, and we link it in with the bad IP reporting, and then we created sub-collections basically on a site-by-site basis so that we could track over time. Basically, we took time slices, 1 hour, we'd compare the 7 a.m. and the 8 a.m. slices, percentage blocked of all the IPs that are available to that site. And we had like hundreds of thousands of IPs in our network. What percentage of them were blocked on that site, and then what number remained. So they could see clearly if they were going to end up with a delivery problem before the end of the day, and the teams who were responsible for sourcing IPs or swapping IPs out or whatever, they would know that they had work to do. So we created the emails and the notification, and that also helped organize, it was basically blockages by site, service, geo, org. We'd let the salesperson know, oh God, this customer of ours is 80% blocked. You ought to give them a call and tell them, we have this great new system and we can see this and we're working on it. Try and be a little more proactive rather than hearing from them 3 weeks after the fact. And so we basically created collections for each of these subcategories and tracked block rates, and then proactively notified the teams that were responsible and notified the customers who might take a hit in advance, right away, in real time, within an hour. People knew they had something to do. And this was a huge sea change. So we prevented the bad IPs from being served to scripts that we know they're blocked on. And now we've notified the people who can do something about the problems within an hour. Then once we had this framework in place, we started to create analytics overall. And I'm sorry, I did not get permission to share screenshots of the system. I actually have I have these if you want to come up and look after the talk, but I can't share them on video and YouTube and publicly. It's private IP. But we created global analytics, so you could see the health of the entire network. So for example, when the East Coast, we were attacked, we had some sort of cyber attack, and we had all these internet outages and site outages, you could immediately see that. You immediately knew what was happening. You could see it. You could see the backlog of inputs that were not getting processed. We could immediately notify our clients and tell them what was happening, and manage what was happening on our servers, because we were building up huge queues, and that was really useful. So we built the global health monitor, and we based it initially on just the HTTP status code. So we took, anything that was a 200 was considered good. Anything that was 300, it was a redirect. It was worth looking into. But it was considered good. Anything that was a 400 was separated from 500s, because they were sort of a different set of codes. But 400 and 500 were considered error. So we could track errors. So created all these collections, again, like sub-collections that were easier to create analytics and visualizations for. So we had the global health, and then you could drill down any number of different ways. You could parse by date. You could filter by date. You could filter by what app. You could filter by what customer. You could filter by what geography. Sometimes all of our Japanese IPs went down at once. You could filter by site code. It was great. All of a sudden, people could see where we had errors and patterns of errors. You could also filter by service. So if a particular vendor, maybe we added some some IPs to the network, and they were working beautifully for the first 3 days, and then they all went down. We would literally know immediately. We would get an email, and it would say, you know, service errors 100% on this vendor. And, you know, eventually we just we automated the process of notifying their support and creating a ticket. I mean, straight through processing, right? So then we drilled down further. We wanted to look at types of errors, and we wanted to provide more overviews. And you know, we just continued going deeper and deeper, and creating more collections and creating more detailed alerts and notifications. And then we drilled down into subnets, because it wasn't enough to say, oh, this particular service provider has a 5% higher error rate than normal, when really that's just because one of their subnets is 100% down and should be taken out of rotation, and they need to be notified. So we automated the taking it out of rotation and notifying, you know, taking it out of the rotation not on a site-by-site basis, but for all sites globally, and notifying the vendor immediately. Then we needed to know, you know, now that we saw what was happening with our IPs, we needed to know, you know, we were spending, you know, I don't know, 25 grand a month on IPs. We needed to manage that more closely. A lot of the quality problem was honestly due to not having enough funds left after all these customers were so disappointed. So we were tracking our costs very closely. And so we built utilization collections and analytics and reporting showing how we were utilizing the various IPs and subnets, and we were able to see what we needed more of based on the forecast of need, based on what the history had been, and that was really valuable. And we just created some reports that would, again, just create task lists for the team that was responsible for sourcing all of those. And we integrated with the ticketing system. So we had, you know, 300 employees, and they were all sectioned off into various hierarchies according to the areas that they were working on. And so it was very easy to integrate in with the ticketing system, and, you know, not create 1,000 tickets for the same problem, but one ticket for the same problem that's affecting a lot of different sites, and then providing the detail. Immediately assigning it to the right teams, and then we were able to track response rates, which was really great with our customers, because here all of a sudden we've gone from a situation where things were constantly down, we didn't really know what to tell the customer, they were telling us 3 weeks late, 3 weeks after the fact, that our data was no good, and we were like, really? Let me look into it, to all of a sudden being really proactive and saying, we got this ticket, we solved it within 15 minutes, you know, blah, 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 and this is our resolution rate. So that was really, really powerful. The team was getting really excited about this stuff. Our overall volume of the work that we were able to process per quarter went up so much that we started being able to clear, on average, it was about $800,000 more per quarter, just from the same contracts and the same customers and the same team. So this was really working out. And then we got really ambitious, and we took it down to per minute collections, which we were only retaining for up to 3 minutes. And this required a lot of mirroring and sort of, you know, basically distributing the compute resources, decentralizing them, because it was a tremendous amount of work to create these collections very, very quickly, and analyze them very, very quickly, and then send alerts and notifications. But really, it was just doing the exact same stuff that we'd already done, but faster and smaller. So more micro jobs. And again, people were just so much happier, because, you know, somebody owns a particular area. It's nice for them to know, like, right away, you know, 2 minutes in, they know that this subnet has gone down, and it's been taken out of rotation, and they're going to need more IPs if they're going to get the data on this, you know, for this VIP customer before the end of the week. And then we realized, you know, we've been storing all the content of the data going across the wire And occasionally, if there was some really mysterious problem and we really didn't know what the issue was, we would, go in and sort of, at the command line, look through, what it was that was in that field that stored all the contents of what had gone across the wire, and it was incredibly hard to analyze. It was very time-consuming, and as the team that was sort of managing the technology and the rollout of all these capabilities, we didn't really have time to dive in to troubleshoot every single script that was going wrong, and we really needed to empower the teams that were writing the scripts, but we didn't want to give them access, the keys to the castle to go and query this stuff for themselves. So we built a mechanism to dynamically query, to basically kick off a process that would create a collection on the fly. So you could put in the parameters you wanted to search for, which were, again, it's like all the same stuff: the account, the org, the app, the site, the geo, the service, the run ID, the work unit ID, line item ID. You could search by all of these things and pull out, time frame, and pull out, what had actually crossed the wire. And you got all this gobbledygook, right? It was like PCAP formatted content, which is like, oh my God, this is awful. And it turns out that there's a lot of tools. There's a whole career that people have where they're forensics experts, and they actually look at what's traversing the wire, and they reconstruct that content into files so that they can actually see the HTML page and the PDF and whatever it was. And you can see exactly what traversed the wire. You can reconstruct it. And so, and these tools are free, so you can just download them and follow instructions. And so, that's how we dealt with that. We would let them query and download the raw content themselves, and then they could basically use tools that were free and available. They were imperfect, so they were like, 8 different tools or something that they had access to, but they could actually really see what was going wrong. And that was just like, okay, we're done. Everybody was happy. It was good for the business. And then we started worrying about, we had throttle technology that, our volumes were so high at this point that our algorithms were suffering, that managed all of our traffic to make sure we didn't hit a site too hard. Like, you don't want to create a denial of service attack. The goal was always to have a very low level of traffic on a very regular basis so that we would collect data and nobody would complain or send us a cease and desist or anything like that. So we decided that we could use this collection to do things to protect us from compliance concerns, from potentially causing a problem with our traffic. So we used the start and end time with the response times from the websites to see how fast those pages were loading, and we tracked historicals on how fast they normally loaded at that time of day, on that day of week, and we could trigger pauses in our traffic and see if we were causing anything, and that way we could further protect ourselves. It was like insurance against the business having any issues. A lot of the sites that we pulled data from, by the way, were also our customers. So sometimes they would call us and be like, we're having a problem on our site, can you just turn everything off? So that's how we got this idea. But man, were they thrilled when they heard we had this. And sending alerts and notifications, based on that as well. This particular site is slowing down. Consider, reducing or halting your traffic for the day. And then the last thing was those configurations. Somebody could make a mistake and configure some very high volume site, for example, to use a very, very expensive service. And we could, just rack up like $28,000 in fees before we even knew that this had happened. That did happen once. So we used since we had this collection, we were continually able to add value using this collection. Using analytics, we were able to pull out the utilization information. So we pulled all the traffic utilization, which is basically what script is running where, when, and we were able to marry that up with the AWS usage data. And our finance team got NetSuite set up So we were able to hook it into the revenues per account and map it to org account, app, site, et cetera, service. So we were able to track cost and margin. And so if we got issues, if we suddenly had an issue where our margins disappeared or plummeted or became negative, we would get an alert. And it was usually a configuration, an honest human error configuration problem. It took us probably 3 months to get the MongoDB set up, to get the proxy instance, proxy manager stuff working, the basic bad IP, tracking, and the scripts going through that common API that we created to create their proxy instance. It took us about 3 months to set all that up. And then after we'd set all that up, we were just able to endlessly and continuously create value and improve everybody's lives and make it so much easier. And it was better for the company, it was better for the sales team. Instead of constantly being the one to get caught with their pants down, or whatever the term you want to use, they were proactively calling the customers saying, these are the things we're seeing, the internet's down on the East Coast, this is how we're going to handle it, our teams are on it. Before it had even hit the news, our customers knew what was happening. And it was fantastic. And the people who loved it the most were the teams that had to deal with the firefights, that had been dealing with all this firefighting for years and years and going through a world of pain. They were just thrilled. So now I'm with another startup. It's also in web data extraction. I'm totally hooked on web data extraction now because we had great experience, plus there's this, this industry is exploding. So we have a brand new start. We don't have any of this fancy stuff. We haven't gotten that far. But we're collecting data on a daily basis from all kinds of different sites. It's not just retail and travel. It's basically anything you can think of. If it's job listings or airlines or car dealerships or real estate listings, job listings, anything. Government sites, airport traffic stats, anything. We're collecting huge amounts of data, and we have our own software which we license, and we also provide services. And big piece of our sales pitch is that we are laser focused on quality, because analytics is only as good as your data. If your data's no good, your analytics is also not very good. Yeah, you can predict and you can sort of, account for gaps in the data, and there's things that you can do about the problem of not having good quality data. But at the end of the day, especially in finance, where they're making data-driven decisions that are either going to make money or lose money, the quality is paramount. And so this is a huge piece of our sales pitch. It's no longer, when you get into this data and analytics space, you don't get this pushback on quality that we used to get back in the day when we were just a cost center. This is like, whoa, you have ideas about quality? Let's do it. And I think we benefit tremendously from telling the story. And this is sort of some of the things that we do in the product to make sure that we are getting good quality as we're capturing this data. So of course on every run we're capturing all of these metrics at a high level. We expect a certain amount of data. We expect a certain amount of page loads from a particular, errors from a particular site. We expect a certain number of, after we do our transformation and we export, to the final output format, we expect there to be a certain number of rows or whatever it is. And we can do a percentage of the previous run, or we can do a count, fixed count, and the next rev, we'll have a range. We have a whole roadmap in this area. And then for data validation, we just got this screen included in the last release. It makes it really easy to do it across many fields at one time. But basically, you're setting your data type and your format, whether or not it allows nulls. You can basically define your format style. It could be JSON, it could be a numeric range. It could be a regex script. So if you wanted to do PII checks, you could script those in. If it's a time value, then you can set, what time is it? Is it UTC time? Is it local time? Which time is it? when the validation occurs, if it's only at runtime or only at the point of export or both. And then you can do like a data row validation script if you have something custom, like VIN numbers for cars or a very specific format. You could do something on that, or you could say, if I have this many categories, then I should have this many products, and you could do all of that sort of custom validation rules on the fly in a script against the data that you've collected. You can do duplicate, get rid of duplicates. You could choose to flag duplicates, get rid of them completely, or raise an error and get rid of them. There's all these different choices you can make, which are different depending on what you're doing. And then each time there's a validation error, you can choose, what we do by default is to take that row and put it to an error file, which makes it, a nice structured error file. It's really easy to analyze, and then increase the error count. So when there are errors above a certain threshold, you get an alert. There's a ticket raised. We have a ticketing system. There's a ticket raised. You get an alert. So this is about as far as we've gotten in my current company. We don't have the big data analytics at this company, but we're figuring all that out now. So we're basically sort of at the data curation stage is what I call it. You basically establish thresholds and monitor those. And I would say for any of you that are starting to do this for your own software projects and in your own companies, I would recommend exploring some of the text analytics capabilities that are out there. So actually some of them are quite easy to use. We just did a hackathon 2 weeks ago for an investment company in London, and they gave us keys to Microsoft Cognitive Services, which I'd never used before, but it was incredibly simple. It was an API interaction, send your data up, and you could get back either image analytics or sentiment analysis, entity extraction. So, instead of having to worry about normalizing names or whatever it is to understand what it is that's in your data, you can do entity extraction. You can normalize places, all this kind of stuff, which is great for if you want to do analytics on really big data. It's nice to create, humanly recognizable data structures, and you can do that with text analytics. So what do you do with these large output files? So one of the things I didn't get into, because it's also more proprietary, is how at this prior company we did analyze all of the large output files, the billions of points of data that we were exporting every day. And there we basically, first we tried to do open source and it was just too hard, so we opted for a vendor called Snowflake, which was great. They basically will read the CSVs off of the file system and allow you to create queries. So you can search for outliers. It's really expensive and you need specialized engineers to implement it, and you're probably not going to be able to do it on a QA budget, so I'm not really going to talk much more about that. What I do instead, at my startup we also don't have that budget. I basically am a serial trial user. I was telling Sabrina I'm a serial trial user of RoadMonk as well. But we basically sign up for trials of visualization tools, which makes it really easy to visualize what's happening in the data and what areas we should look into. So Trifecta is one that's really, really, really good for QA. Again, it's expensive if you want to use it in production, but you can trial it here and there if you want to think about what cases you should be testing, if you want to think about what what issues you might have in this particular build. You can use it periodically here and there. It's incredibly easy to use. It's like Excel on steroids. It really is incredibly easy to use. Another one is Tableau Prep. Again, incredibly easy to use. You literally point and click and point at your data store. It could be a database or a file. They all sort of work this way. And then they bring it in and you can do all kinds of things with it. Power BI is another one. We just used it in this hackathon. That was the tool they wanted us to use. And it's incredibly simple. I'm not going to show you any actual visualizations. but just to give you a sense of what the interface looks like. I mean, you can literally, I've imported some very basic data. You can literally just click around and try all of these different ways of visualizing your data, and then you can create all of these filters on your data, and it's like incredibly easy to use and incredibly insightful. If you don't have a tool like this at your disposal, it's a good one. And the trials are, they work really well. So, you look for outliers and gaps and things that are the wrong type of value. You can write, validation routines that pull out things that don't make sense. But use these tools that exist to explore your data. Don't try and do it by hand. It's way too hard. This is something that we did, as part of the hackathon. We had like a day or two. They gave us a bunch of companies to look at, and so we went onto Twitter and we looked at the company mentions, key product mentions, and then we ran it through sentiment and mapped it to the financial data for that company stock that's available on Yahoo. Historical data over time, and we were able to see that this one particular tweet actually moved the stock. This soccer player, Marc-Andre ter Stegen, he's a goalkeeper for Barcelona. He said, "Oh, playa Adidas sneakers," and you see these huge spikes all of a sudden occur, probably magnified by algorithmic trading. But it was amazing what we were able to see from this publicly available data in a day and a half. And sort of every company that they gave us, we just went out there and found all this data, and we were able to see all these insights just like that. Really interesting. So obviously, this is an influencer that you would like to track. So you can just put this in the QA context in your particular application, and this can work for you as well. This was, 3 of us, but this was one graph, but we did, a lot more than this. It was basically two days we pulled this together. So where do we go from here? I think, and obviously I'm steeped in this world of quants and doing data-driven investment decisions, and I can't stop thinking about data-driven QA decisions. I think there's a huge opportunity in this field for testers and for QA people in general, because you have all the right skills for using these tools and using this approach to help your teams. And obviously, data is so cheap to store now. We all have huge amounts of data in every system that we're working on. So, looking at pattern recognition for data quality, looking at techniques and algorithms that search for patterns, looking at ways to automatically generate your test data or your test cases, figuring out ways to train AI to make sure that your tests stay, healthy and that they actually work. What I recommend there is I'm a huge fan of this guy, Jason Arbon, who is the founder at test.ai. He sort of differentiates himself from AI-enabled software testing companies like Mabel and Testim, by saying that he's really taking he's using AI to generate a graph model on the fly so that you can basically have the AI learn how to test an app, rather than the approach that Mabel and Testim are taking, which will look at sort of 10 different ways to identify elements on the screen that you have, and you have elements you're interacting with in your automated tests, and they're looking for ways to sort of self-heal those automated cases. Jason Arbon is taking it, into the next phase, I think, for all of us, and using true AI to realize that you're testing a shopping cart, and these are the things that you should test, and these are the things that you should control, you should interact with on screen. So I've included some links here. I don't know if I'm going to be able to send these slides. I'm happy to send these slides out. But there's a really great webinar that Jason Arvin gave recently at a Camp AI, and there's a link here to that. Then there's also, I've included a link here to some machine learning algorithms. I don't know how well I'm going to be able to, okay, it's loading. So this is just a very high level treatment of the topic, but the fun thing about this is it shows you how to do it, how it works, explains what it is, and it gives you all the common machine learning algorithms, which honestly, if you're looking to bring this into your QA process, you should just go through, oh, it's not showing. It's not showing. Well, anyway, this link, you'll be able to see it. Just lists out all of the common algorithms that you would use, all the typical approaches, which would enable you to create those data structures on the fly and identify patterns, to take note of, and how to analyze huge amounts of data. What else is in here? Sorry, this is a little bit wonky. Okay. I'll just do it this way then. What else is on here? Oh, Quantopian. So this is a bunch of quant wannabes who are sharing all their algorithms, and there are fantastic lectures on there about how to use Python, and then how to use Panda to create all of these data structures, to create your time series data, how to deal with overlaying different data sets to work together. That's a really hard thing to do sometimes. And so they have all these great lectures, and I would recommend looking at them. They have hands-on tutorials where you can go through using Python, use NumPy. You'll see. I recommend spending time there. And the last thing is there's great courses. So once again, back to, I'm a huge fan of Jason Arvin. I think I said that already. But I think this is really important for testers to do for their career, is to really explore what's happening in this area, because I already see it. I saw it in QA. It was incredibly hard to find intelligent testers who were effective at finding relevant issues. Well, you can imagine what's happening now in the data space. It's like impossible to find people who know how to do automation and to do it with great quality, and to test for quality, and to have that quality focus. But AI and ML, I think, is probably the future. Once we incorporate analytics into QA, we're going to want to take advantage of all of the AI and machine learning innovations that are happening all around us. And a lot of these things are open source, and they're available for you to play with now. And I think this is a great time to go in and really explore and become an expert. So this is my goal. For the next year, I'm going to get a lot more proficient, and I'm going to use my current job to make that happen, hoping to spread a lot of happiness among the people in my company that are dealing with quality problems at the moment. I didn't say we had quality problems. We don't have any quality problems. All right, so that's it. Does anyone have questions? Yeah.
You talked about previous companies, the data that you were analyzing and then not getting able to use the capital. How do you share data? Or do you have any thoughts on sharing data so that it is accessible beyond just the same exclude people that's kind of taking this data? So how do you make this data something actionable stuff, accessible stuff?
The most common use, what? Oh, the question is, how do you make data accessible so that people outside your org can collaborate with you on it? And we distribute data all the time. We're obviously collecting data, huge amounts of data, and distributing it. So there's all different ways you can do it. The simplest and probably the cheapest is CSV in an S3 drive, S3 bucket. and give people access. And then they can pull it down into whatever analytics tool they're using. But CSV files, another thing that we do is, we've been doing a lot recently, if you do have big data analytics infrastructure, one of the popular formats that we're doing now is Apache Parquet, which allows you to create tables that are like files, but they're queryable tables. And Spark just immediately analyzes them and makes them available to analysts. But for us, the analysts at the funds, they're not technical, but our data is instantly in their screens, and they can drag and drop and mix and match and try this visualization and that and test this and that. It's really straight through. There isn't really a big heavy data pipeline in the middle. But CSV is probably the simplest if you don't have that kind of analytics infrastructure, which you probably don't.
Yeah, I guess that just to clarify a little bit what I was thinking, is part of the problem that you guys see is you provide these tables for the
That's where the visualization tools are good. A screenshot. Set up a trial of Trifecta or Power BI or some sort of visualization tool and give them a screenshot. Like this, we created a simple screenshot of the universe of Twitter data we collected. A simple screenshot of a visualization. Yeah. Yeah, and if there's so many of these analytics companies, you can probably get a pretty long-term trial. A lot of them don't even have data to demo their wares. One way we explore data sometimes with customers holding their hands, like a lot of the shops that are earlier in the process of becoming quant shops. Power BI has a web interface where you can basically on a screen share, both of you can be going through and drilling down and interacting with that interface. There's just great tools that do that. Tableau does that. It's expensive though. Tableau, they don't like to give away the server, capabilities for free. It's harder to trial that. Microsoft Azure loves to give out credits, and who knows, you might fall in love. You might license their stuff. So, yeah. Yeah.
Literally use a lot of different open source products and projects. Are there any challenges in maintaining them or managing them, and what patches before you use it?
It's a terrible problem. It's very difficult. I just looked up Little Proxy today. I'm mentioning it to you. Yes, the question is, do you run into any trouble using open source technologies with managing versions and changes and quality in those individual libraries? And I think it's a terrible problem. It's very difficult. It's amazing to get these libraries that represent the productivity of incredibly inspired and very talented engineers, and you're basically expanding your team. But what it comes with is this complete, you just don't know what the release term is, and you don't know what bugs are in there, and there isn't a formal, QA process. And we had a lot of these issues. It's just a matter of making sure you have enough regression testing around the libraries and making sure you have good control over your build process so you're not downloading the wrong version of the library and sending it out there untested. Anyone else? Is that it? It's 1 o'clock.
Pretty much at 1 o'clock anyways, but thank you for the questions and for coming today. Thank you for us for the great presentation.
Thank you. Thanks for having me. It's amazing how that works out. Look at that.
Yeah, there you go.
Would have been better with screenshots.